Okay, welcome to Research Methods for the Summer. Today, or week one, we're going to talk about what is science, and we're going to talk about naturalistic observation, and you'll have a naturalistic observation assignment, and we're going to explain that today at the end of the video. So first of all, let me just tell you a little bit about who I am and why would I teach this class. Well, I kind of think research methods is fun. I enjoy teaching this class so much. I have a PhD in clinical psychology, which means that I have a significant background in research. A PhD is sort of like a degree that you get with research. You have to do research to get that degree. In addition to that, I was on the research faculty at Yale University for a while in the School of Medicine, and I was the director of research for a perioperative anxiety research group while I was at Yale. I was also the director of research at a company called EPII, and I'm currently and have been for about 12 years-ish, maybe more than that, more than 12 years, the principal scientific advisor for a company named Soul Naturals. All of these have given me a variety of experiences in doing research. For you, maybe you're worried about this class. Maybe you're kind of afraid, thinking, oh, research methods, that's going to be hard. I don't like math. So think about what the value for this might be in your life in terms of critical thinking, in terms of understanding a little bit more about what's out there. Lots and lots of people will say, oh, well, the research says. And so it's important for you to know what that actually means so you can evaluate for yourself. Does the research actually say that? So I think there's huge value for this in your life, even if you don't use it academically, and you will use it academically for your future as you move through the psychology major, in terms of evaluating research, and probably as you move through the FHD major as you evaluate research there also. Next thing to think about is high school versus university. And thinking about some of these things, I'm not sure that you got a great orientation out of high school into what does it mean to go to a university. And so let me just cover a few things that I think that when I thought about them, I thought, you know what, people don't actually talk about this much. And maybe students aren't really aware. You know, there's a difference, but it's hard to pin down exactly what it is. And so one difference is the amount of time in class. Of course, that's easy, right? You go to school a few hours a day as opposed to all day. Another big thing, though, is who is responsible for your learning. And generally, the model in high school is that the teacher is responsible for your learning. Whereas at university, you are the one responsible for your learning, and the teacher is a resource for you. So the teacher will give you lots of resources in order to find out information. The teacher will help explain the information so you can understand it. You can ask questions, etc. But the responsibility for learning is yours. And so you are the one who has to be active and not passive. The high school model, you're just sort of sitting in class with your knowledge mouth open and the teacher's pouring knowledge into your brain, right? And here at university, you got to go get it. You got to go get that understanding. And so just showing up in class and being passive doesn't work very well, especially if you're not paying attention. So ask for help. Ask for help. In the summer, just email me and we'll figure out either I can answer your question through email or we can talk, set up a time. Pretty flexible, okay? So here's another little bit about the difference between high school and university. A lot of times in high school, you are trying to find out what the right answer is. And so the teacher gives you the right answer, and then you feed it back to the teacher. That's not a very useful model for learning in life. There's often not just one right answer, or maybe a number of ways to figure out the right way to do things or to find out. Learning by listening is useful, but you also need to create a lot of effort. And so effort means that you are expanding on your readings. So you might read chapter one in high school and just figure, if I read the chapter, that's enough. But in university, it's often not enough to simply read the chapter. What you want to do is really work the chapter to understand it. And so you'll look at ideas in the chapter and you'll try to expand on those or apply them to your life. And you'll practice doing recall. Recall is really important in terms of learning. That's how you learn. Learning through just recognizing is not good enough. It's a little bit useful, but it's not a very high level of learning. And so you want to create some understanding out there with all kinds of resources. Feel free to Google things to get a better idea. Feel free to use Chat GPT to teach you concepts, not to write for you. Definitely, definitely not to write for you and not to do research for you in general, but ask it to teach you about ideas. It's pretty good at that. And so you can use Google, etc. Let's now talk briefly about plagiarism. First of all, obviously, it's not okay to cheat. It's not okay to use somebody else's work or words and cut and paste them, pass them off as your own. One of the things you're going to practice doing in class and in your assignments is you're going to practice learning how to paraphrase. How do I look at an article and get some idea of what they're talking about and put that in my own words so I can talk about it without cutting and pasting and without using the same words? When plagiarizing happens, that results in a fail, automatic fail for the assignment, potentially an automatic fail for the course because we take academic honesty pretty seriously here at SVU. Plagiarism is counted when you use five or more words in a row from another source. And so if you've got five or more words that came straight out of another source, that gets flagged by Turnitin as plagiarism. And you can get a zero on that assignment. So make sure that you're learning how to paraphrase. We're going to work on paraphrasing a little in Unit 2. This is Unit 1, experiment, or not experiment, sorry, Unit 1, Science and Naturalistic Observation. Unit 2 is coming next. Okay, so let's go. Today we're going to talk about natural observation. We're going to start with basic context for what science is and how does psychology relate to that. So in terms of overview, we'll look at a definition of science, we'll look at the scientific method, we'll talk a little bit about how to gather data using empiricism, we'll talk a little bit about hypotheses versus theories, and how science is and should be reproducible. So here's one definition of science. It's not the definition, but it's one that does a pretty good job. We're talking about something that's systematic, a systematic enterprise, not so systematic. Well, actually, we're going to talk about that in a minute, so I'll wait. It builds and organizes knowledge. And so what you want are testable explanations. Science is about testable explanations, not explanations that are not testable. And so we're talking a little bit about what is an empirical question versus a non-empirical question. And sometimes if you say, well, why did he do that? Let's say you see a man and he goes and hits a tree. You might say, why did he do that? Well, science isn't really going to help us figure out why he did that very well. We could have a lot of hypotheses, but we need a testable explanation that we can look at over and over in some sort of a test. And so you could use observation. You could give him a little personality test. You could come up with some ideas that might be supported, but you need to have an empirical question. So you might say, maybe people who hit trees have a lot of trauma in their past. That might be your hypothesis. And then you give all the people who are hitting trees, you give them a little test to see, did you have trauma? Well, that would be an empirical question. And so that could be a scientific investigation. But just simply asking why and sort of musing about it, that's not science. So, what makes science different is that instead of regular observation, it's systematic. That means instead of just you glanced out the window and you saw something, what you're doing is you're glancing out the window every Tuesday at 10 o'clock for 1 hour, and you've got a very specific paper that you're filling out, recording your observations. That is an example of what systematic observation is. Of course, it doesn't have to be once a week, like in my example. It just has to follow a system. So it's not whenever I felt like looking out the window, I did. Science as a discipline didn't just suddenly happen in the 20th century. Sometimes people think of it as, well, science happened recently. It wasn't really a thing before. They just listened to magic or kind of came up with weird ideas. That's really not the case. People were systematically observing and they were describing and experimenting even a long, long time ago, all around the world. And we have lots of cultures who kept organized and built on this knowledge as much as they could. So, for example, King Nebuchadnezzar in the book of Daniel, he actually ran an experiment looking at the health effects of the king's diet to Daniel and his friends' diet. And so they had two groups. They had one, the king's group, and they had Daniel's group, and they observed them for 10 days. They compared the results at the end. Now, it wasn't randomized, so that's part of being an experiment. So it wouldn't qualify as exactly a modern experiment. And it's unclear if they were equivalent groups at the beginning. In other words, we don't know what their health was like at the beginning of the study. It might have been that Daniel's group's health was already better because he was already using a diet that was healthful. But this is a great example of an investigation into diet using science. Ayurvedic medicine, this is a kind of medicine that long standing history of this in India and surrounding countries. India has a lot of Ayurvedic texts that describe their medical knowledge over the course of thousands of years, diagnoses, treatments, even surgical procedures. They used empirical observation. In other words, empirical means that they're using their senses to examine what's happening. I saw it with my eyes, I heard it with my ears, etc. And pretty detailed documentation. And so that's another example. When we think about science, the goals of science are to describe, predict, understand, and control. Sometimes people don't mention the control part because they're worried. But there's nothing wrong with doing a lot of controlling as we look at science. Particularly, you might want to control the parameters around which you're gardening. Let's say you want to figure out, how do I best garden? Will be useful to use science to describe, predict, understand, and control. So there are lots of different ways that we figure out science, that we figure out how does something work, or different methods or plans that you can use to conduct research. So this name of this course is Research Methods. In other words, we're looking at the methods from which you will use to create your scientific results. Research methods are based on observation or empiricism. And so there are three ways you can observe humans. You can self-report. That means you're giving them a questionnaire or you're asking them a question and they're responding. You can observe them, behavioral observation, or you can check their physiology, like take their blood pressure, look at their B12 values, look at how much inflammation, etc. You want to make sure scientific questions are testable. They have to be falsifiable. You have to be able to measure them and then say, yes, this supports my idea or it does not support my idea. Questions about why, like we said, usually are not observable. We have to see what happens. The why is not really visible often. It's harder to identify. So we can look at theory for explanation, but that theory has to be testable in order to contribute to science. And so a couple elements of science, again, are this systematic approach we've talked about and empirical observation and evidence. Empiricism being, I could see it with my eyes, hear it with my ears. In other words, I'm using my senses. Systematic would be that it's structured, it's logical, it's organized, it's consistent, it's repeatable. So you're using a system to collect your data. It's not just randomly collected whenever. Empiricism means that you're relying on the knowledge that comes from observation. And so there are lots of ways to get knowledge. Using your senses is one of those ways, but that's how we do science. We understand scientific knowledge based on observation or empiricism. And so the study that you'll do this week, the naturalistic observation, this will be based on empiricism. Another element of science is that it's testable, like we talked about. You have to be able to prove that your theory is wrong or right or wrong. It's hard to prove something is right, but you can definitely prove that something is wrong. And so what we do is we look for evidence that will either support or not support our theory. And so think about what's testable and what's not testable. An empirical question is a testable question. Empirical questions and science also has to be reproducible. You have to be able to show it over and over. And so when you can show it over and over, that means it's a reliable finding. You can see it again and again. I have a cake that I make. People like my cake. It's pretty reliable. And so every single time I make it, people like it. That's reliable. You also want to make sure you communicate how you did the thing. And so if I said, well, you could make this cake too, just use chocolate. That's not a very useful way of describing how I made the cake. And instead, I would give you a recipe and maybe a video and maybe coach along with you. And then you would be able to make the cake just the way I made the cake. That would be reliable. Predictive power is another element of science. This means that scientific results are useful. There's a predictive power to them. And so if I said, every time I make this cake, people like it, it's a good cake, I could say that this cake then will make people happy, of course, right? That's the predictive power of my cake, I guess. What's the predictive power of your naturalistic observation? That's something to think about. When you figure out what that observation will be, you can think, okay, what is the predictive power of what I just observed? And again, we're going to talk about that at the end of this video. Another element of science is that it has peer review. And so that means that other people have looked at what you've done and they say, yes, that's a good method. And it fits with what we know about science and what we know about your observations. So you're accumulating evidence and you're accumulating findings, and people throughout the world or in the scientific world are then building consensus through doing multiple studies. Now, that is the ideal. That often does not happen. Sometimes you'll have one study that looks really good and people talk about it for a long time, but they kind of ignore other studies that maybe don't support or don't agree with that one study. There are a number of examples of those. And we'll talk about that a little bit in the ethics section, which is the last week of this course. Your study needs to be based on a theory and needs to have a hypothesis. And so we're going to do a little bit with that this week in your naturalistic observation study. You'll sort of just kind of try out those ideas. Your results are either going to fit into that theory and support or not support your hypothesis. And so then those results can refine that theory and contribute it to the scientific goal of understanding, right? So that's sort of the idea, is that we continue to study, continue to refine, continue to support what seems to work. Again, this is the theory about how science works. It doesn't always really work that way because there's no universal police that manage science and that say, here, we should do more investigation of this. It's not controlled that way. But we do want to find out things. We want to know what's true. And so we're going to go with this back to this idea of empiricism. How do we know something is true? How do we know that it's a thing? Because that's what we're doing in science, is we're trying to find out, we're trying to get information, which again, remember, describe, predict, understand, control. Okay, epistemology is the study of how we know things, pretty much. And so, in other words, what justifies knowledge versus I just have this opinion or I just have this kind of wild hair, I guess, that I think something is true. You may know people that think something's true, and then you have different data that doesn't support what they think. This is probably a common experience. And so you might say, well, how do you know that that's what happened? And so they're going to tell you how they know, and they're going to know something through a variety of different methods. Here are some ways of knowing. Authoritarianism is one way. In other words, an authority said so. Somebody you respect says so. So you might say, uh, Dr. Allison said, I hate to be an authority, but in this class, you could say, well, Dr. Allison said that research methods involves looking at a number of different methods in which are ways that people do research. Okay, so that would be authoritarianism. Most of the time, what we're doing is we're appealing to an authority, like my doctor said, or the American Medical Association says, or Galileo said, etc. Recognized authorities. Empiricism, like we talked about, you're using your senses, your sense perception, your observation. If you're going to use rationalism, then you're using reason and logic to justify your knowledge. You would say, well, I know such and such is true because it makes logical sense and it's based on these assumptions and those make sense. There are a number of other ways in which you can justify knowing, like it just feels right to me. That's one way. Revelation is a way of knowing. It's a way of knowing something is true. And I think it's probably the most solid way that you could know anything. Everything else, it seems that you could be fooled. You might have your senses fail you. Sometimes people create deep fakes that are not accurate. They look right, but they're not right, etc. Authorities can be wrong. So how do you use empiricism? Well, the scientific method is how you use that observation. So again, we talked about being systematic. You use a plan and you stick to the plan that you developed. There are lots of different ways to have different plans. You're going to use one this week called naturalistic observation. That's one plan. And so you'll have read chapters 1 and 2. And in chapters 1 and 2, you should understand the following things. I've got several slides on these. And so I'm just going to run through them really quickly. And you can get more information from chapter 1 and 2. Also, if you still are having trouble understanding the differences, like I said, you could ask ChatGPT to quiz you. You can ask ChatGPT to give you examples. You can ask it to come up with examples and then a multiple choice test, something like that to help you really understand this. Okay, so we're going to talk about these briefly. Population versus a sample. In a population, this is the large group that you are pulling your sample, your small sample from. And so a population might be something like all of the people who ride bicycles, or it might be all of the people who enjoy buckwheat for breakfast, or it might be all of the people who attend Southern Virginia University, or it might be all the people who have had a cold in the past 3 months. So a population is a large group of people. A sample is a subset of that population. And so if I said I have a sample from Southern Virginia University of 100 students, that would be a subset of that population. And then you want to think about how did you get your sample? And that's your sampling method. You can do a random sample, or you could have a convenient sample. A random sample is when there's some random way that people are selected to be in your sample. For example, if I was looking at all the students at SVU, and then I asked the registrar to choose every 17th student, that would be a sample, a systematic sample. If I got the number 17 by a random method like rolling dice or something, then it would be a systematic simple or a systematic random sample. A convenient sample is much more frequently used, and it's kind of like, if you want to be in my study, please sign up. Here's a QR code. Or I'm asking the people in my class if they'll do this. Or I'm offering extra credit to all the psychology students to do this, etc. An experiment versus a non-experiment is another thing that we discussed in chapter 1 or chapter 2. And so an experiment is something that has a random assignment to a group. You either have a control group or a group that has some sort of treatment. A non-experiment would not be randomly assigned to group. And so you can still do an experiment and have it be called non-experiment if you can't randomly assign to group. And so to go back a little, you've got a group that has that's control that doesn't get anything, and a group that gets some sort of treatment. When you're doing random assignment to group, it's not the same thing as random sampling. And so what happens is these people are already in your sample. You already have them. Whether you got them as a convenient sample or a random sample doesn't matter at this point. They're already there. And then you decide, are they going to be in your treatment group or your control group? If they're in your treatment or control group, you have to figure out which one it is. And if you figure that out randomly, that means they're random assignment. And so if you, for example, draw names out of a hat to be in your experiment group or your treatment group versus in your control group, that would be random assignment. And so that makes it an experiment. If it's not an experiment, it means that you did not do random assignment or you couldn't do random assignment. Independent variable versus dependent variable. I think most people covered this in middle school or high school. The independent variable is the one that the researcher controls or either gives you more of or less of. It is the variable that they're testing, sometimes is a way of thinking about it. Dependent variable is the variable that you're measuring. And so if I'm looking at the effect of orange juice on happiness, I would measure happiness, and orange juice would be my independent variable. One group would get orange juice and one group would get something else. And then I'm going to measure their happiness. Okay. So that's an example. If you want more practice with that, again, you could ask ChatGPT to give you a lot of questions or a lot of quizzes working on identifying independent and dependent variables. Extraneous variables are variables that are in your study, but that don't really have an impact on the outcome. And so it might be true that it's raining in the next county over, but that doesn't affect my experiment right now. Or it might be true that it's daylight when I'm doing this, but maybe that doesn't matter. Maybe that won't affect my results. A confound, however, would affect your results. And so let's say you're doing a study looking at vitamin D, and some of the people in your study are outside hiking all weekend, and some of them are not outside hiking all weekend. And so the ones outside hiking all weekend might get more vitamin D being in the sun that would be an extraneous variable, but also a confound, because that would affect the amount of vitamin D in their body. And so that might affect your dependent variable. We can also look at lab research versus field research. Lab research is controlled. A lot of times you might be looking at very, very controlled conditions, like you have a little petri dishes full of bacteria, etc. Field research is outside of the lab. And so you're looking at more real life research in the field versus in the lab. Internal validity versus external validity. These are two ways to look at how useful a study is in terms of its ability to recognize or be able to capture kind of like truth. So when you think valid, you think true. And so how true is the study in terms of identifying the cause and the effect or identifying the relationship? That would be internal validity. External validity is how generalizable the study is. In other words, how true is it for other people? And so if I do a study at SVU, it may not apply to a group of people who are doing yoga in their 60s who live in New York City. It might not apply. So the external validity may be limited. Descriptive statistics versus inferential statistics. A lot of these concepts these are like an introduction to these concepts, and we'll talk more about them throughout the course. But you do have some beginning ideas here that let's start with these and then we'll kind of keep repeating them. So you have two different types of statistics. Some of these statistics will be able to describe the people in the sample. Those will be descriptive statistics. They are describing who is in the research. Inferential statistics are where you're comparing two groups or you're comparing the group to general population, or you're trying to make some comparison between what is happening in one group versus what we think would happen if it was just an average day, for example. And so we've got descriptive statistics versus inferential statistics. In descriptive statistics, that includes measures of central tendency. And so what is the middle of things? Central tendency. That would include the mean, the median, and the mode. It also includes the range. What's the range? What's the low value and the high value? And it includes the standard deviation and the variance. And so I would encourage you to, we're going to spend more time on this later, but I would encourage you to get comfortable with those definitions. Correlation is a inferential statistic that looks at how things are related, and we'll spend a lot of time looking at that when we get to Unit 4. But just kind of as a understanding now, correlation helps you see the strength of an association. Are they strongly related or are they not related? Whether or not something is statistically significant really means that the statistic that you came up with when you did your calculations, is that an indicator that this is a finding that is unusual, or it's a finding that would be different than a null finding? So the null hypothesis would be there's no difference here between A or B. Statistically significant would mean there is a difference between A and B. How big that difference is a different question. But you could say, yeah, no, there really is a difference between these two conditions. Type 1 and type 2 error have to do with this idea of, is there really a difference, or was there a difference and you didn't find it in your study? And so if you missed it in your study, then we would call that a false negative. Like you're saying there was no difference, but there really was a difference and you missed it. So that false negative would be a type 2 error. Type 1 error is a false positive, where you're saying, yeah, there's a difference, but you didn't see it. And so you would say, no, we didn't see that there was no, I'm sorry. I just said that. A false positive means that you think that there's a difference when there really isn't a difference. And so that would be a type 1 error. You think there's a difference, but there really isn't. And so, like we said earlier, you can't prove that something exists, but you can disprove. So the example there would be like the white swan, black swan idea. As long as you've only seen white swans, you think black swans don't exist. But you can't prove that black swans don't exist. All you can say is, I haven't seen one. At some point, if you see a black swan, then you can say, well, I can disprove now the idea that only white swans exist. So I can disprove, but you can't really prove. The hypothetical deductive method is something we talked about earlier today, where you have a hypothesis that comes out of a theory. And so you start with your theory. I think this is how things will go. I think if I water this tomato plant, then it will grow. That might be my theory. And so my hypothesis would come right out of that theory. And it would say, if I add 3 cups of water every day to this tomato plant, then I should have some growth, right? So that would be your hypothesis. A hypothesis is a very specific prediction that would come out of a theory. When you're manipulating a variable, for example, let's look at the tomato plant and water again. And let's say water is the variable you're going to manipulate. Then you're deciding how much and when the tomato plant gets the water. And so it might be that you're going to compare a group of tomato plants that get rain only, a group of tomato plants that gets 2 cups of water a day, and a group of tomato plants that get that gets 2 cups of water every other day. So that would the variable of water would be manipulated by you. So it's your independent variable, right? Okay, when we think about what the literature is, we'll talk about a little bit about that next week. The literature is all of the articles that are out there that are published and accessible. You can have some articles that are out there in people's file cabinets. They're not really, I mean, they could be part of the theoretical literature, but they're not part of the literature that you can access. We talked about epistemology, ways of knowing things. We talked about what's an empirical question and what is systematic. Pseudoscience versus science. So pseudoscience is something that looks like it's scientific, but it's really not scientific. And so sometimes people will say, oh, this is how this works, and here are the data, but those data really are not, they're not valid. And so we would call that pseudoscience, or you'd have what looks like a scientific explanation that really is not scientifically based. And so pseudoscience is sort of like fake science. Looking at skepticism versus cynicism, I really like this kind of idea because when you're skeptical, what that means is you're looking for data. You're open to what science would tell you. I'm skeptical, show me the data. What do the data say? When you're cynical, you just sort of don't believe stuff. And you're not very open-minded. You're close-minded. And so you would say, oh, all that stuff is stupid. That is not a thing. And you would refuse to look at the data. And so look in your life at areas in which you are cynical versus skeptical. The ideal is that you're skeptical and open to information. All right, experimental psychology versus clinical psychology. Clinical psychology is where you're probably using therapy to help people, or you're using testing to get information from people. Experimental psychology is, like we talked about, it is doing experiments, and it really has very little to do with a clinical therapy. You might use findings from experimental psychology to inform the practice of clinical psychology. We talked about the definition and the elements of science. We talked about reliability and validity. A heuristic is a simple problem-solving method. It's something that you kind of use to quickly jump to a conclusion. It can be really useful, and sometimes it can really get in your way. Confirmation bias is one example of a heuristic. And if you don't know what confirmation bias is, Go figure that out, go look that up and identify the ways in which all of us humans use confirmation bias to help us quickly make some progress, but it can also really get in the way of us understanding truth. And then remember that those three ways to get data from humans: physiology, observation, behavioral observation, and self-report. Okay, we talked a little bit about type 1 and type 2 error. Type 1 is a false positive, type 2 is a false negative. And so hopefully this slide will help you understand the difference between those two things. And then we're going to do an article walkthrough where I identify different scientific principles in an article. So for example, we'll look at the different elements of science, maybe some extraneous variables, etc. We'll do that in a second. Actually, I think that's going to be a separate video so that these videos aren't super, super long for you. And then we'll do a separate video on the naturalistic observation project. Okay, so we'll end this video now.